Hey guys, welcome back to another episode of Java on Azure Container Apps. It's been a while since my last video update, and that's because I've been working on making Java experiences on Azure Container Apps generally available. If you haven't heard that, be sure to check out my announcement in the video description below. But back to today's topic, one of the top concerns of running production apps in the cloud is memory management. How do you identify memory issues for your apps running in a remote, managed and secure cloud environment where you may not necessarily have all the controls to expose and download data telemetry for offline analysis? Well, in this video, I'll show you how you can easily do that with managed Java components and the Eclipse Memory Analyzer. All right, so we'll start by introducing a memory leak in our code with the owner's cache. And the way this works is every time when we refresh the owner's page or call find all owners, it's going to try to see if the owner already exists in the cache. And the default behavior is that when we compare an owner, it actually looks at the memory address of an owner. And obviously, when you create a new owner object, the address is going to be different, and therefore indefinitely increasing the size of the owner's cache and eventually introducing a memory leak. Okay. And now what I'll do is I'm going to use a tool. It's called the WRT. And this tool is an HTTP-based load test tool. And with this tool, we're going to hit the owner's page with 100 connections. And while that is going, let us head over to the Managed Java Components page. Right now, we're looking at the Azure Container App environment page, and under Services, Java Components, this is where we're going to find the Managed Java Components. And the one we're going to use today is Admin for Spring. This is based on the Spring Boot Admin OSS project. And once you've chosen the component, you also have to bind it. And what I'll do is I'm going to leave a link in the video description that I'll walk you through how you can create and bind Spring Boot Admin for your app. Let's now head over to the Spring Boot Admin dashboard, and right off the bat, you see the indicator has turned red. This means that the Spring Boot actually endpoints for my user app are no longer healthy because a lot of resources are currently taken. Okay. We'll now scroll down to the bottom of the page and look at heap memory used. On this graph, there are two lines. The top line indicates memory ceiling, and I've intentionally kept that low so we can easily hit that. The yellow line is the amount of memory that is currently used. So you can see there's a lot of spike up and down because my app is asking for a lot of memory, and at the same time, GC is happening trying to keep my memory in check. Okay, so you can see there's a lot of GCs happening, all of which indicates we have a memory issue. So now to dig deeper and see what's going on with my memory, we're going to go to the JVM tab, and under heap dump, we're going to download a heap dump from Spring Boot Admin. Heap dump contains essentially all the memory information. And now we're going to open up the file that I've already downloaded in the Eclipse Memory Analyzer. And from this tool, you can see we have the owner's controller class that is occupying almost half of the memory. Okay. And then there are a number of tools you can use from this page. For instance, you can look at the top consumers. You can look at leak suspects. The one we're going to use is the Dominator tree. This is a tool that is going to give you a tree view of the largest class in my app, and it's sorted in order. So if we expand the first line, we can see the owner's cache is indeed the culprit here. It's taking 43% of memory, and which is owner's cache is a name that matches exactly with the name that I have in my code. Okay, so that's how you would identify the memory issue in your app. And lastly, to solve this issue, let's go to my other branch in my code. I'm going to override these two methods, which defines how an owner object is compared. As a result, existing owners are no longer added to the cache, and it eliminates the memory leak. Let's test this out. We're going to use the same WRK tool to produce some load. And going back to the dashboard, we see the memory consumption is no longer approaching the limit, and garbage collection is also happening at a much slower rate. Well, hopefully this is helpful. You can try the memory leak sample from the links in the video description. Thank you for watching, and see you in the next one.